Okay, so continuing on with the bring-up of these boards that I designed in KiCad, and for the last 2 days I've been looking for tiny little shorts that occurred because I've been using solder paste and a stencil on this board, and there happened to be a little bit too much solder paste. So I realize now that properly mounting the stencil on the PCB before applying the solder paste is very important, because if the stencil lifts off the PCB just a little bit, you end up with too much solder paste on certain pads, and that can create shorts. And such shorts are really time consuming to find. It takes a lot of rework. It takes a lot of patience to figure out where exactly the short is. In this case, I'm going over the power rails, and I have working power rails, which is 12 volts and 5 volts. Or actually, no, I only have 12 volts because the 5 volt rail is also shorted, and one of the 3.3 volt rails is also shorted, that is the rail that goes to the peripherals. And I think I found a place where I have a short, which we'll take a look at under the microscope, and we'll remove that short, and we'll see if that will unblock our 3.3 volt rail. And you can, let me just pick up the microscope and find my gloves. So looking at this chip here, so this is the EtherCAT controller, and it has one of the pins on the top side here, which is connected to 3.3 volts, and it seems to be shorted to the adjacent pin. So let's see here. So we'll look at this pin under the microscope. And we can see this short is invisible to naked eye, but under the microscope we can see that there is definitely a tiny solder bridge between the two pins. So I'm going to remove that solder bridge, and then I'll check the 3.3 volt rail to see if the short is gone. I'm gonna use a bit of flux on this. Actually, this gets me thinking that maybe this bridge is actually supposed to be there. I'm gonna zoom in on the schematic, or rather on the PCB, and see what is. We have a, right, okay, it definitely shouldn't be there. So let's try to get rid of it. Because some pads can be connected and there is no solder mask between pads that are too close to each other and directly connected, which is a little error when generating the Gerbers, that I didn't check for the thickness of the solder mask. Like, what do they call it? It's solder mask dam. That's the proper term for it. So I should have checked that there is no places on the PCB where solder mask dam is too small. But that's a minor issue for now. The bigger issue is getting rid of the little solder bridges that are caused by solder paste and actually getting the board to power up. So I think it's gone now. Yes, it's definitely gone now. Let's check the power rail and see if we get any short on 3.3 volts. Yeah, the 3.3 volts is still shorted, and so is 5 volts. So we need to look farther and see if we can find any other places where things don't look as they should. So moving on, I'm going to look around this chip and I'll see if any capacitors look like they could be shorted. Let's see, so we have, oh, there we have a short. That's one. Capacitor looks fine, but there is a tiny little solder bridge there which we need to remove. I'm going to use the wig. Yeah, did I remove it now? I think I probably did remove it. Let's check. Yeah, it's gone. It's not the prettiest solder job though. We can fix that by putting some flux on this portion of the chip and heating it up a little bit, so we make sure that all of the solder gets drawn to the pads and not creating solder balls around. We don't want even the tiniest little solder balls because that could mean a short that's hard to find later. I think this looks fine. Looks fine. Now I'm going to look at the capacitor here. Is that solder or what is that? Looks like there is a bit too much solder on that capacitor. Could be a solder bridge. Most probably not, but still worth checking. So I heated it up a little bit. And now let's see here. Where is it? There. Yeah, that's a bit of solder there. I think I'm going to wick it and just make sure that it doesn't have too much solder on it. I'm going to wick it from the side. Which is easier in this case because I have the chip right next to it. So I keep this soldering iron at 360 degrees. While my hot air station is set to 250 degrees. And this has worked as a very nice combination because if something needs quick resolder, I can heat it up with 360 degrees solder iron tip. And for the hot air, I use much lower temperature because that can melt connectors. And going beyond 250 degrees is a bad idea because things start melting at that point. Let's see. Do we have a better capacitor now? Not much difference. Not much difference at all. Did I melt it? Did I melt the solder? Very excited about finally fixing this short on this last board. So I fixed all of the power supply shorts on the other two boards. I've made 3 boards, and so I know it's not a PCB issue. It's a solder bridge somewhere. We just need to find it. And I'm looking forward to actually starting to program these boards and testing all the other peripherals. But I need power first. Let's see. Do we have a better looking capacitor now? I'm going to move this capacitor a little bit. So I'll use the heat gun to heat it up completely. And move it just a little bit. Make sure there is no possible short there. So the tricky part here is that even if I have the multimeter connected to the power rail constantly, and I can hear it beeping all the time, if there are multiple shorts, I could actually fix one of them and then maybe introduce another short by resoldering some capacitor. And so it's really hard to know when you are done. So I started instead to use the microscope to check every single component, which I should have done before. But at first I was just thinking that I'm going to fix this real quick. But that wasn't the case. So I went over all of the components multiple times and tried to desolder and resolder things that I thought looked shorted without looking at them through the microscope. But that didn't solve the problem. So this is something, this is a short somewhere else. What the fuck? Why am I not placing this capacitor right? This is really annoying. It's like when I look at it with my eyes, I think it's positioned like perfectly. But looking through the microscope, it definitely looks like it's offset. Which I doubt is the problem here, but I want to fix it anyway because I don't want to spend too much time on this. I want to make sure that everything looks as perfect as possible to diminish the possibility that I introduce any new shorts. Okay, yeah, this will have to do. So let's have a look. Look at that. I actually moved it too far away now. Damn it. I should be soldering it under the microscope. So this is 402 components. Not the tiniest components, but still getting to the point where it gets hard to actually solder them by hand. And solder them properly. Let's put some flux in this, make sure that it reflows. Okay, this will have to do. Let's see. The capacitor is, yeah, that's much better. Anyway, so what else do we have here? We have, I'm going to be going over all of the parts connected to this rail and looking if I can see anything that looks like a short. That looks fine. bit too much solder paste there, but that doesn't short anything. There's plenty of space between the pads. Okay. So we have the, let's see, we have the capacitor and resistor here, which doesn't look like it's shorted. And neither does the resistor look like it's shorted. Okay. So looking at this, oh, look at that. That looks like it could be shorted. But what is? Let's see, where is this somewhere? Right. Okay. So this is this pin goes to ground, or actually to 3.3 volts, and this is unlikely to be shorted. But this this could be shorted. It wouldn't be a short that would affect our 3.3 volt rail, but it's still a short. It's still a possible short. Let's see if I can get this just fixed very quickly. You see how tiny they are? This is the tip of my soldering iron. Okay. I need to get myself a microscope with an arm that I can easily move around. But this will do for now. Okay. Let's see if there is anything else here. There is, I think I checked that one, and this one I've checked as well. So moving on, let's see. Let's check this one. Doesn't look like a short to me. Looks pretty much perfectly soldered. Slightly off the pads, but not so much that it could be shorted. Let's see, so we have another capacitor here. Does this look shorted though? Let's see. It doesn't look really shorted to me. It doesn't look shorted to me. I don't know, maybe I should resolder it. Let's have a look at the other one first. This one looks okay as well, I think. A bit too much solder though, but still okay. There is a solder ball there, which I should get off. Board. Let's see. Put that solder ball. Okay, we can have a look at this one as well. That looks fine. Does this look shorted? It actually does look shorted. It doesn't look shorted when I look at it without the microscope, but under the microscope I think it looks like it could be shorted. Let's get this fixed. Let's wick it off. I'm going to heat it up a little bit first. I'm going to use a bit of flux to make sure that the solder can flow better. Okay, and then we can lick it off. Let's see if I shorted anything else here and wicking it off. There's a lot of solder on these pins, but it looks a lot better now. Let's see if the short is still there. Yep, the short is still there. Okay, so moving on with what else can we check here? I don't think I checked, right, I need to check the CAN bus transceiver capacitors here. So we have VDD3V3 connected to the CAN bus transceiver capacitors and to the CAN bus transceivers. Let's see what we get here. All looks fine. That one looks like it's soldered, but not perfectly. So that's for later. Not a big issue for a prototype like this. But let's have a look at this one. Could there be a short underneath this chip? It looks like there is a lot of solder on it, so it could actually be shorted underneath. I think I'll just in case I will desolder this chip and wick off any excess solder underneath it. This is the CAN-FD protocol chip, and it comes in a very small package, which tends to, if it gets too much solder on the pins or on the pads, then it can actually short the pins to the ground, because it has a ground pad underneath as well, so there could be a solder bridge underneath the chip. Coming off pretty soon. Right? Oh, have a look at this. This is horrible. Oh, this is definitely something I should fix. There's a lot of solder. Look at that. There is a huge amount of solder on this. Like, ooh, look at that. Look at that. Look at that solder ball. This is definitely going to be wicked. And maybe, actually, I'm gonna check if this moved my short now. Now the short is still there, but this definitely needs to be fixed. There's probably some similar case somewhere else, which I will eventually find out. But I'll start with this one. put some flux on this, on the pads, and then I'm going to stick the chip back on. And heat it up until it starts wobbling on the pads, which means that it has properly caught up to the pads. So I move it a little bit. If it moves and doesn't go back to where it was before, then it's not soldered. Once it starts going back to the proper position, then it's soldered. Okay, almost there. So this was definitely, probably one of the shorts on the 3.3 volt trail. We'll find all of them eventually. Oops. So once the tweezers get hot enough, they actually start melting connectors if I touch the connectors. It seems to be caught, but it's there is very little solder now on the pads, so it's not really moving back to the position. But I think it's caught on the pads. We'll see if there are any other issues with this chip later. For now, I just want to get rid of the short. Let's see. The crystal has a lot of solder as well, but let's focus on this capacitor and the chip itself. But it looks better than before, though. I think it should be soldered. So I'm just gonna check. The short is probably still there. Yeah, because I didn't have any short when I removed the chip there. So that one is checked, and we have these ones, and also I'll check this one. Let's see here. Does this look good? Yeah, I think I checked this one already though. What is it that I didn't check yet? I haven't checked the stuff on the back, so I'll have to do that. I'll check this. I don't think this is an issue. I have removed the chip without getting rid of the short. So that's that. What else do we have here? We have the temperature sensing as well. That was a problem on another board where the temperature sensor filtering capacitor was shorter. But I checked that temperature sensor multiple times now. But I haven't checked it with the microscope though, so I'm gonna have a look at it as well. So this was, this is this one. That one is supposed to be there, I think. It's one of the connections between the parts. Yes, it's supposed to be there. And that one, everything looks okay here. It shouldn't be shorted. So, what could it be? Let's have a look at this. I've desoldered and resoldered this capacitor so many times now. Let's see. What about the other one? Is there supposed to be a solder bridge there? I don't think so. Is this solder bridge a short? No, not that one. Actually, which one was it? There. Is that a short? Or is that supposed to be there? Oh, that's supposed to be there. Okay. This doesn't seem to be shorted. So what else could it be? Right, have I checked this chip? I think I checked it. Current sense resistor. Right, so this here is the rail that's shorted. Ha! Ha! Ha ha ha! Have a look at this. Ha ha ha! That is definitely not supposed to work. God damn it! I thought I fixed that. But without looking at it through the microscope, it's impossible to see that it's actually shorted. So tiny. Could this have been the short all along? Let's have a look. It's still shorted. But this was the... Oh, it's still there. God damn it. Okay, now my wick is stuck to the board. 360 degrees on a solder iron tip is not enough. Not enough heat. I think it's gone now. I'll check. Is this gone now? Yes, it's gone now. Well. Okay, let's check. This is the moment of truth. At least one of them. Let's have a look here. So I'm gonna do like this. See, have I gotten rid of the short? No, it's still there. It is still there. Okay. So continuing on with the search for the short. Find the short. This one's a bit off. Maybe I should resolder it. Is there anything else here? Okay, so that is the 5 volts that goes into the regulator. I really don't like the fact that there's so much solder there. It could actually still be shorted. It could still be short. I'm gonna resolder it. Just to make sure. out any possibility that it's shorted somewhere underneath this LDO. Wait. I think I need to check this again. So I was checking the 3.3 volt rail, whereas I was supposed to be checking the 5 volt rail. Ah, we got rid of the short on the 5 volt rail. That's good. Okay, so I don't need to desolder anything here. This was the problem on the 5 volt rail. But we still have a short on the 3.3 volt rail. So we need to look farther on the 3.3 volt rail to make sure that all of these parts are okay. So let's just have a look here on this. What do we see here? Okay, this one was fine, and this one was. Is this one fine as well? Not the best soldering job, but it looks okay in terms of having any shorts there. I don't like when the solder gets outside of the pads like that, so I'm going to fix it. So where's my soldering iron tip? I need to find my tip of the soldering iron. Put the solder back on the pad. It doesn't stick out. I don't think that is an issue there. I'm going to double check. I think it's supposed to be there. It looks like it's supposed to be there. Yeah, so we should have 3 of them between the parts there. 1, 2, 3. These ones are okay. Now, is there any other one that would be shorted? Maybe it's on the back. I think I checked everything. Besides, maybe this will in here. So this is the reference voltage, and it goes to the resistor there. Does it? Why is it going to the resistor? No, it goes to the capacitor. Yeah, it goes to this capacitor here. And this capacitor goes to ground. Does this look shorted? I'm going to wick it up a little. It has a lot of solder there, but not so much that I would imagine it would be like shorted, but still a bit too much. It's better to remove it just in case. Do we still have the short? Yeah, the short is still there. So this is not fixing the issue, but it's still something that I prefer to fix along the way. What are you people saying in the chat? I can see that there is something there, but I have another window over the chat. There we go. Good morning, Martin. Good morning, Rashad. Good morning, Damien. Yeah, it's nice to keep the old boards around. Keep them around as donor boards. I had like a business idea once where I thought that I would like recycle components from PCBs, but I realized it would be way too much work because I got some PCBs that I tried to desolder, but they weren't soldered with leaded solder, so it was very hard to get things off. You had to heat them up really much until I just realized it was a total waste of time. For the price you would get for components that are used, it was totally not worth it. Okay, I think this one is on now. So this should be everything on the top side. I think I checked pretty much every single component that's connected to this 3.3 volt rail. Could I have missed anything? Is there anything else that I could have missed? Let's see, did I check that one? I think I did. Okay. Okay, I'm gonna flip the board and see if I find anything on the back side. Otherwise, I'm completely out of ideas. Let's see. So I'm gonna hide the top layer. I'm gonna look at the bottom layer. There's quite a few things here that could be problematic. Let's see. Let's have a look here. Oh, this is solder ball there. Where is the plastic? There it is. Doesn't look like it's shorted. I don't think so. I'm gonna check this chip actually. So this chip has the 3.3 volt rail going to it, and it does have a few solder bolts around. So removing the solder bolts is probably a good idea to begin with. This chip has D2D3 coming in on this side. Let's see here. And the capacitor is, yeah, that capacitor. I lost one of those capacitors. Maybe I'll find the capacitor. So that's the pin that could be shorted underneath the chip. I'm gonna check everything else before I remove this chip because it looks reasonably good. Let's see what we have here. This looks reasonably good. What exactly is that? Huh. Okay, that's just a track within, let's see. Is that just a wire? That's probably just a track that shouldn't be there. Yeah, it's just a small track, which I'm going to remove. So this goes to the inner layer. So having the track here is not, I don't think that's necessary. Right, we just need to make sure that we don't disconnect with the copper here. So just this. So I'm going to press, no, I'm going to press, I think I'm going to press I. Okay. So, okay. So checking this one as well. This one looks like it could be a bit off. But it's the other one. It's not the one that's selected on the drawing. If that is an issue, it probably isn't. I'm gonna check this anyway. Because there's a lot of solder on it. This is the last little detail before being able to power on the CPU. Figuring out where the short is on the 3.3 volt rail. Okay, let's see here. So this is, let's see if it helps to flip the board. I think it's going to flip it the wrong way anyway. So I've been looking here now, and now moving down to this place here, which also has some components on the back. Oh, look at that! 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 That's going, and once that is gone, maybe my board will work. Or maybe I'm just celebrating before actually looking whether this is supposed to be there. This could actually be supposed... Yeah, this is probably supposed to be there. Damn it! I thought it was a solder bridge, but it wasn't. I was celebrating too soon. Okay, let's have a look. Okay, it's actually in this direction. We have two capacitors there. Connected there, and it's this one. Yeah. It's actually this one, and it's that one. Yeah, that one there. They don't look shorted to me. There's definitely a lot of solder, so it could be a good idea to remove any excess solder on the parts that are part of the 2.3 volt rail, just to make sure that that's not the issue. Well, it's up to you to decide. Do you want to set up a live stream? set up a live stream, then go ahead and do it. If you don't want to set up a live stream, then don't do it. Okay, so looking at this again, is there anything that looks weird here? I think that anything that's that kind of depicts actual work when solving some issue, it's always helpful in some way. And personally, I think the videos that I watch on YouTube, the most useful ones are the ones that are not specifically made to explain some concept, but rather the ones that are the ones that are about solving some issue. And as part of that, there is a lot of things that the person does that can be valuable in solving other problems as well. So it's probably going to be useful, definitely, in some way to somebody if you live stream it. So what have I not checked yet? I checked everything, I think. I don't think there's anything else that I haven't checked on a 3.3 volt rail. But where is the short? Could this be so unfortunate that there is a short in the board on this particular PCB? What? Wait. Did I just delete something? Okay. I should have run the delete unused tracks and vias, like clean up tracks and vias, but I haven't done that. So I'm thinking I'm gonna do that once I have saved and pushed this to Git, so that I know exactly what has been deleted later. But where is the short? Is this never gonna be solved? Okay, I'm gonna resolder this chip as well and see if that could fix the issue. But first I'm gonna check if I still have a short. So we have that one and that one. No, that one's ground. Yeah. So we got a short across this capacitor, which is not intended. Shorter. So next I'll probably connect some power to this rail and see where things get hot. This is that shorter? Let's see. This was not an issue. This chip. Putting it back on. And, yeah. I'm out of ideas on where to look next. This pad is quite good at leading away the heat because it's connected to the ground floor. So it takes higher temperature to melt the solder on it. What have I actually forgotten to check? Maybe I should have a look at the regulators themselves again. Maybe there is some short on the regulator. Maybe I should try desoldering the regulator. 3.3 volt LDO. I like QFN packages. I think they're much easier to solder, or they're much easier to center than the QFP packages, which have pins. Kind of getting a little stuck there because I think there's very little solder on the ground pad. It's not gliding as much, but I think it's soldered now. Okay. So where have I forgotten to check? Is there anything that could be an issue here? Yeah, the short is still there. Could it be some little strand of copper from the wick somewhere? Some little tiny strand of copper that I do not see. Okay. Could this be shorted? check this out. This one is shorted. Let's fix that short. That's a similar short that I had on the 5-volt regulator, but this is ESD protection diodes, or rather over voltage protection. So it's a similar package, and it has similar type of short. I'm gonna wick it off now. Let's see if it's gone. Yeah, it seems to be gone. That looks like it could be a tiny strand there. I don't know. I'm gonna check with the multimeter if I still have the short. I still have the short. I'm gonna just make sure that these two are soldered on properly. So this was a short between VDD3D3 MCU and another pin here. So while this shouldn't affect this 3D3 power rail, it was still something that had to be fixed. But there is probably something similar somewhere on the 3D3 rail. And it could actually be that maybe somehow the power is going through some component, and then I don't know, maybe going to some other pin, which in turn is shorted to ground or something like that. So I have to check as much as possible.